So I know, there we go. Thank you for recording. Yeah, so I'm Julie Lyderson. As I mentioned, I'm the navigator in the electronics department at North. I get to work with students from that first point of contact where they're kind of exploring program options and deciding, might this be a fit for them, through persisting through their program, and then ultimately securing employment in the field that they have trained for. And also get to work with employers and do a variety of other things, but working with students is definitely the highlight. And Heather is a program manager in electronics. And thank you so much, Heather, for moderating today. So feel welcome to just relax, see what resonates for you with the presentation today, knowing that you'll be able to go back and view this later. So we've got a lot to cover. So open invitation, anyone who wants to explore this further, by all means, don't be shy about reaching out. Glad to talk through it from start to wherever your interests lie and see if this is an appropriate program for you. And most importantly today, though, we've got several things we want you to leave today with a good sense of. And those are, what programs do we offer here at North within the electronics department? How might I determine if any of these are suitable for me? What will I learn and how long will it take? What does instruction look like? Oops, excuse me. Is there any kind of an internship involved? Is there really a demand in industry for these skills? Can I earn good money? And who do I contact to learn more? And that's me. Contact me. So we're a relatively large department in that we do have our 6-degree pathways. And these are listed over here in the left-hand column of this slide. We've got electronics technology, healthcare technology management / biomedical equipment technology. We refer to that as our biomed degree. Industrial power and control, electronics engineering technology, which is a transfer degree, mechatronics and IT controlled electronic systems. And those that are color-coded here, electronics technology, for instance, you'll see in blue. You'll also see across from it the certificates that are embedded within that degree. Same thing, so healthcare technology or our biomed degree, there aren't any certificates embedded within that particular path. Industrial power and control, there is a certificate embedded. Electronics engineering technology, not a certificate embedded there. Mechatronics and IT controlled electronic systems also have certificates embedded. So in our department, when we're talking about our applied associate of science degrees, we commonly refer to those as 2-year degrees. Now, that doesn't mean every student is going to complete in 2 degrees. It really depends on what quarter do you start, because we are open enrollment. We're not a lockstep program that requires you start fall quarter or winter quarter. It's really up to you. Depends on, are you a full-time or a part-time student? So there's a number of other variables that impact how rapidly you may progress through the program, but generally we say 2 years for an associate degree. Our certificates over on the right-hand column, most of them are roughly 1-year certificates. The shortest credential we offer, the shortest term, would be the very top one under the certificates column. That's our Aviation Electronics 1 wire assembly. And that can be completed in as few as 2 quarters, but generally 3 quarters. And I really like, Heather gave me the analogy of the rungs of a ladder. Embedded certificates, really helpful to think of them in those terms. So you could say you started with Aviation Electronics 1, spent 2 or 3 quarters doing that, and then said, you know, I think I'll continue on. You would have the option of working toward the Aviation Electronics 2 certificate, or electronics technology, for instance. At that point, you might say, you know what, I really want to move into industry and get a job related to what I'm studying. And then maybe I'll come back and I'll build on that and I'll turn that into an associate degree. So that's what we mean by embedded certificates. So quick question. So what's the big deal about electronics? Is this even relevant to me? So before we really launch into distinguishing one path from the other, it's important to think about, does this really matter to me? And when we're talking about electronics, what I'm referring to is the flow and control of electrons. So we think of this as charge and electricity. And electronic components are what are the devices that are used to control this charge or this electricity. So we can steer the electrons, we can store them, we can resist them, we can somehow manipulate those to do what we want them to do. So I want to make this kind of relevant on a personal level. So take a moment, think about a recent day, think about today, yesterday, how were electronics involved in your life? So for instance, have you turned on a light today? How did you wake up at the desired time? Was there any mode of transportation involved in your day today? Have you used a phone? Any other screen, video games, TikTok? Where's your food stored? Are there any tools or any type of equipment that you use in preparing it? How do you clean your clothing, dry your clothing? Have you had any appointments, gone to school or to work, and any electronics involved there? So probably for all of us, it's pretty apparent that electronic devices are a really important piece of our day-to-day life today. And going further, we live in a time now where we use electronics and technologies where robots and artificial intelligence, things like this, are capable of doing work with greater ease and efficiency than humans. And this is an important piece. We'll get back to this later, but let's move on from there. So if I had to drill down to some of the most important traits of our program, I would want to make sure to share the following. We are focused on technician training. And when I say technician, generally I'm referring to a 2-year degree, perhaps a 1-year certificate, but we're talking about individuals who have proficient technical knowledge and skills, as well as a practical understanding of theory in their particular domain. So we're talking about electronics here. We are applied programs, as Vanessa mentioned at the beginning of this event today. We emphasize hands-on learning in our labs. Our faculty come from industry, so they have this expertise developed from, learning, going through a variety of training programs themselves, doing the work, and now teaching it. The curriculum in our department is common across all of our degrees, and by that I mean there are a number of classes that students will complete regardless of which degree or certificate pathway they're completing. So for instance, every student will complete a DC electronics course. Every student, with I believe there's one exception, will complete an introduction to robotics course. Every student will complete an IT essentials course, which is focused on sort of hardware and networking. So that common curriculum is really helpful in terms of students get into their programs and they find out really where their interests lie. They have this opportunity to kind of pivot toward one degree or another without losing time. Our programs are designed to prepare students for the workplace. We do have one transfer degree, which we'll touch on in just a bit. And some of the basic information that's helpful to know right up front, entry requirements. So for math, we want to see that either a student has completed a class we call Math 81 at North, which is a basic math that shows you are ready for algebra, or there are equivalent placement alternatives. So if you are coming straight out of high school, it may be that you have completed a math class within a year of enrolling in this program here at North, and there's a form we can have you submit electronically that shows, yeah, you've met the placement requirement. Or within our department, our faculty have created a math placement test. We just want to make sure that students are well prepared to launch into our programs. English, students need to place into English 98. There's a placement test for that. For any 1-year certificate or an associate degree, ultimately students are going to need to complete English 101. Doesn't mean you have to be to place into that class right to get started, but eventually want you to know that English 101 will come into play. If you are an ESL student, at North, we have a leveling system through level 6, and we want to know that students have completed through ESL level 4B to make sure they're not at a disadvantage in our courses dealing with a lot of technical terminology. Computers, many students coming in have adequate computer experience, and happy to talk with folks about that. We do offer a class called Business 169, which will provide that experience if needed. And then in terms of scheduling, our classes generally meet twice a week on Monday, Wednesday, or Tuesday, Thursday, or once a week as a hybrid class. And fall, winter, spring quarter, those are all 11 weeks long. Summer quarter is condensed, only 8 weeks. Most of the classes in the electronics department are going to start at 11 a.m., at 2:30, or at 6 p.m. So just some of the basic information before we go further. Now, I want to talk about a few highlights of how instruction happens in our program. And so to tell you kind of what does it look like. Faculty, as I mentioned, they come to us from industry. Some of our faculty are adjunct faculty, so they're continuing their work in industry now, and they come in and they teach a class periodically. Most of our faculty are full-time. We have 3 full-time tenured faculty. We have another full-time faculty who also manages our labs. So you're in very good hands there. Hands-on applied programs, as we mentioned, we tend to have a model of lecture followed by lab. And even during the pandemic, we've been able to have some in-person labs. All lectures have been remote online, but we have been having in-person labs throughout pandemic with strict social distancing guidelines in place. Teaching lab assistants, it's common that we hire students who have gone through our programs and through specific courses as teaching assistants or lab assistants in those classes. Those are paid positions, fantastic work experience. And for students who are interested, we have you talk with your faculty if you'd like to be a TA in the future. Peer students, our students in the electronics department and the college at large, they come to us with a really broad range of experiences. So we have people who are changing careers. We have folks who are straight out of high school. We have engineers who come back to us and say, I've got all this theoretical knowledge, but I don't have this hands-on practical lab experience, and that's what I'm here for. So, you're absolutely here to learn from each other, and everybody brings something to the table in our classes. Industry guests, we will have guests come into your classes and provide their sort of personal or a professional lens into various opportunities in industry. Relevant class connections. I'll just share one of my favorite classes to observe is our industrial robotics class, and you get to really see what students have a personal interest in. So for instance, I've seen the musician who taught the robot to play the keyboard, taught an industrial robotic arm to play the keyboard, or the student who is into fiber arts who taught a robot to knit in the round, or the 3D printing student who 3D printed their name in puzzle pieces and how the robot assembled that. So really fascinating and opportunity to personalize your learning. And internship, and I'll tell you a little bit more about internship in just a moment. So in terms of completing internships, we have 2 programs that have internships built into those degrees. So I remember I mentioned there were 6 degrees. 2 of those have internships built in. One of them is our biomed program, healthcare technology management, the one with the long title. Students there generally complete an internship in their final quarter of the program in a hospital, a medical facility, or with a medical equipment manufacturer. This is required for their degree. Great opportunity. In the mechatronics program, students, we encourage you to complete an internship, and that is built into the program. But we also have an alternative. A student can choose from several approved electronics classes, and they could take 2 classes in place of an internship if that's preferred or if that's a better fit for scheduling. We have a large number of students who have completed Boeing summer internships. This is a very well-regarded, fantastic experience for students. It's a competitive application process, and we are absolutely here to help you prepare for that, to be a strong candidate. Students who do that, some have gone on to work for Boeing, some go to work for other employers. And if you are in another degree that doesn't require an internship, that doesn't mean you can't pursue one. So it might mean it's not required for your degree, but Perhaps you're completing a degree that has a technical elective requirement. It's possible that you could complete an internship in place of taking a class, for instance. Students apply for their own internship. We do have support available with that effort. And this is really practical work-based opportunity that we strongly encourage. It's a chance for you to try on an employer or different work environment. So we do encourage it. I am going to go ahead and show you a video. This is about 5 minutes, and I think it's going to give you a real feel for the programs, and then we'll kind of get into some details.
Look around yourself. Do you have a smartphone with you? Do you see a computer in the room? Is there some sort of screen? Is there lighting, heating, ventilation? Not only can you use electronics for electronics purposes, but in the electrical industry, a lot of controls and electrical circuits are done through electronics.
We're seeing unprecedented demand for jobs in electronics.
Yeah, I got hired straight out of out of my last quarter. Like, if anything, that is a testament to how good this program is.
One of the big drivers is that baby boomers are retiring. In the electronics industry, and this is across the board, whether it's industrial power or the biomed or aviation.
I am learning as fast as I can because most of the staff is retiring. Like, it's pretty much the whole of the plant is retiring within the next couple of years.
There's another driver as well, is there's new technologies. Automated manufacturing is becoming a really big deal. And so there's new things that are coming about with robots and programmable logic controllers and the emergence of IT into electronics.
Local industries such as Boeing, Amazon, Starbucks, because Boeing is such a large company, but there are a lot of small contractors, and those contractors are also looking for skilled employees.
I think ours is one of the most diverse of all the programs in the state. Many of the programs, they have good programs, but they have a specific focus on a specific subject.
So we're going to start with voltage, but ultimately when we go out to the real world.
This was the only one that was offering like the full EET course with the AC theory, DC theory, like breaking it down all the way to Ohm's law and then right back up to solid state. And there weren't a whole lot of schools that were offering that kind of level of education in the electronics field.
When students finish our programs, most of them will walk out with a 2-year degree. The 2-year degree could be industrial power and control, could be mechatronics, it could be healthcare technology management, which is biomedical technician, it could be electronics engineering technology, it could be electronics technology. So there's at least 5 degrees, and then there's a variety of certificates.
Voltage, amperage, or resistance, and then again the scales.
In our Introduction to Technology class, they will have direct interface with industry because the folks that are in industry come in and teach the courses.
I tell my students what I'm teaching you does not change. There's not a version 2.0 or 3.0. This is physics and electronics. It's the laws of physics and electronics, and they don't change. Once you've learned them and mastered them, they won't change. You own them for the rest of your life.
We've seen so much grant money come in. It's just been phenomenal. We support really expensive programs like fiber optics, which most schools only teach it in theory. We teach it in depth.
I am a hands-on kind of learner.
They want working on the equipment. They want the hands-on experience, and they want to solve the problems. They want to see how equipment works, from the bolt and nuts all the way to the entire humongous systems.
I've never had so much hands-on in a class before. The instructors here are amazing because you run into snags along the way and they're right there and not only just help you but encourage you to try and figure it out.
Our broadband program, we have significant new equipment. Our fiber optics program, our industrial power program. we could open 2 emergency rooms with all the equipment that we have in our biomed area.
We have 2 brand new robotic systems. That is, you can see those robots in the industry settings as well.
There is no typical student. We have hobbyists. We have people who aren't even interested in going beyond the first couple courses. We have international students. We have domestic students. I've had students in their 70s and some high school students. There really isn't an average student.
Diversity is a big deal here.
It made going to school a lot easier, knowing that you have teachers who are behind you and not trying to put roadblocks in your way. So, which has been an experience throughout most of my career.
It's about $12,000 for 2 years, which, you know, if you go to a private school or go to the UW, you're going to be, I mean, yeah, it is a bargain in the world of education. But the thing that really excites me is students getting jobs. I mean, that is really what this is about for me.
Okay. So before we go on, a couple things I want to call out from that video, and then, you know, we can take some questions. One, this was filmed in about 2018. I think we're working with 5 different, Heather's is that right? 5 different industrial robotic arms at this point.
Yes, that's correct.
Yeah, and the reference to tuition. So really for most of our 2-year degrees, we're looking at about $14,000 as total cost. So we're talking tuition and other expenses. And if you're a Seattle Promise student, by chance, know that we've got about 90 credits funded through Seattle Promise. Most of our degrees are going to hover right around 100 credits. So most of that would be covered. And then I think that those were some of the corrections. But are there any questions at this point, Heather, that we want to address?
You know, there's no questions that have been in the chat. There was a person who left the presentation because I think they were thinking this was going to be about aviation technology at South. But yeah, so nothing else has been in the chat. So this is a great time if you want to raise your hand, unmute yourself. We're here.
Yeah, I think South's program was unable to participate in this today.
Yeah,
So
I gave them our contact information and encouraged them to reach out to us, and hopefully if they need a connection, and if anybody here needs a connection to another program, Julie and I are happy to do that.
Absolutely. Yeah, so the big question, how long does it take? You know, what we do is we generally start with a sequence of coursework, and this is what we recommend. But as I mentioned earlier, the pace is going to depend on several other factors, like are you full-time, are you part-time? Most of our students are working at the same time that they're going to school. They're not necessarily working in the field that they want to be working in. Most aren't. Are you attending summer quarter? So there's a lot of other variables to look at. As you may be aware, not every class is offered every quarter in each department. So we want to kind of build out a plan that works for you. But if we had to quantify it, it's fair to say 7 or 8 quarters for a full-time student is about what it takes to complete an associate degree in the electronics department. Most of our classes are 5 credits. So a typical full-time student is taking 3 classes, 15 credits. Summer quarter, you might remember I mentioned that's condensed down to 8 weeks. And so it's more common that a student would take fewer than 15 credits, so maybe 2 classes at 10 credits. Part-time student, it could be highly variable. Some part-time students will finish in 2.5 years, or say that's 10 quarters, but it really depends on your individual pace. You can start any quarter. We do prefer that you start fall, winter, or spring, and that's because we can get you started right off the bat in our technical courses that are, we have a map that's contextualized for electronics and DC electronics. Those are 2 classes we really want students to start with. We've got 2 instructors in those classes, which is fantastic. And Heather, were you going to add something?
Yeah, I was gonna say there was a question in the chat specifically about do you have to intend to complete a 2-year degree, or can you go after some shorter specific certifications? So I don't know if you want to answer that.
Yeah.
Or...
Yeah, well, yeah, and no, you don't have to. I encourage students when we are initially building a plan and they're thinking, you know what, I think I want to just take a few classes, or I want to do a shortest term certificate or a 1-year certificate. I still encourage them to just keep a 2-year degree in mind. And part of that is because of funding. Sometimes if we have a larger plan built out and can get funding approved for that, it doesn't mean you have to complete that. You might say, you know what, I accomplished what I set out to do here, and I'm done for now. Or maybe I'm shifting direction, but no, you don't have, doesn't mean you have to complete a 2-year degree.
We actually, I was just thinking of one of our former students. She had come in with a prior degree and was just coming in to look for some really specialized training. And in the end, she took a 3D printing class and 2 robotics classes with us. And that was enough to get her into a really great role with Blue Origin. So, it is even possible if you have really specific areas that you're wanting to learn and address, that might be a single class, that might be 2 classes. So while from a workforce perspective, like going out and finding employment, those larger certificates, those longer certificates or those degrees would give you a very well-rounded skill set. Maybe you are just wanting to come for something really targeted.
And seeing that our time is really going quickly here.
Oh, what time is it?
So it looks like we're about 27 minutes in.
Oh, you're right. Okay.
So I'm going to kind of go quickly. I'm not sure how that happened. Is that really possible? So one of our degrees is a transfer degree, and I want to just quickly, you'll have an opportunity to go through these at your leisure. But I want to point out, we've got our electronics technology degree. This program, what differentiates it from the others, it's got aviation electronics coursework involved, as well as technical electives. We've got our electronics engineering technology degree. What differentiates this one is you've got several engineering, physics, and calculus courses, and students can apply to a bachelor's program in electronics engineering technology at Central Washington University to transfer into that program. We've got our biomed degree with the long title here. What differentiates this is, one, you do an internship, that's a required element. You'll take some chemistry, medical terminology, and a project management course as well. We have mechatronics, which is a very unusual program. It's a 2-college partnership. You will focus on electronics training at North, and at Shoreline Community College, just up the road, you will focus on machine maintenance courses. You'll take your robotics, at least one robotics course at North. Another could be taken at North or Shoreline, but it's a really uncommon partnership. And it's sort of a cross-training degree because it's this integrated broad skill set. Next session will be on mechatronics. Industrial power and control. This is going to include, this is where you get into really high voltage, safely working with high voltage. Industrial motor controls and drives, energy generation and conversion are a couple of courses that differentiate this from the other pathways. IT controlled electronics, kind of a sort of housed in electronics and in IT. It's a combination of IT and electronics. And I'm going to scoot through because, as I said, I'm very surprised that we're this close to done. Is that right? Does that look right to you, Heather? Are we really?
Yeah, no, it is. Yeah, we're a minute away. I think just one of the things that might be important just to mention outside of funding you might receive through Seattle Promise is there's a lot of other financial aid resources because these are programs that are workforce development focused. They are, there's a whole other pot of money that can cover the tuition related to these programs. And then there's also things like the Washington Opportunity Scholarship. So even if for some reason you're not a Seattle Promise student, there are lots of ways to get your education funded.
And like I said, you'll be able to have a look at these slides later. I'm going to click through to the end. Oh, employment outlook. the show me the money slide. You'll want to have a look at that. Where a lot of our students go to work, where do they land? You can have a look at this. Steps to get started. If you were ready to get started, contacting me can be a great first step. Talking about funding, it can assist with that. Talking about placement for classes, it can assist with that. And with that, we've got some frequently asked questions as well. And looks like we're not being booted out yet. So,
We have
okay.
45 seconds. So
We have 45 seconds. Well, I thought I had timed it so well, but I guess I didn't. So in the mechatronics session, if you'd like to attend, there'll be just a little bit of overlap, not much, but let's go back for the 30 seconds we have to this employment outlook. 2 job titles that are highly representative of what our students are qualified for when they graduate. It is fair to say that our graduates tend to start at a minimum of $24 as an hourly rate. If you look at these chart wages for these 2 job categories, you'll see the median right in the middle